My name is Russ Festino. I'm a developer advocate for Algorand. All right, so new to Algorand blockchain development. And what I'm going to cover here is a few things. Number one, what are the possible solutions for blockchain? What's a good solution to build a blockchain application for? And what are the features for developers? We have a lot of great tools we'll be going through today in our toolbox for developers, which keeps on growing and growing with the developer community. And then also, how do I get started is another common question, as well as what kind of solutions, how do I get started building solutions? And brand new to blockchain, we got a section here we're going to do up front on that as well to get your whistle wet in terms of this technology. So the agenda we're going to follow here today are blockchain use cases with a section on blockchain basics. We've got layer one features. Now, layer one, for those are new to blockchain, are features that are right on the blockchain. It's built into the protocol and it's available right on the blockchain, as opposed to a layer two type feature, which is typically like an SDK, like JavaScript application you might be writing that performs certain things. So we're going to cover that in depth in the second section. And then great developer tools. It's all about the tools, right? So blockchain use cases. First one I want to talk about here is the props network. It's a turn app users into loyal financial stakeholders. It's a reward system, right? So props platform extracts blockchain technology complexity for apps. So they have widgets you can incorporate into your applications and websites. It's a very simple API for loyalty programs. And it's SEC approved token that they have. So the token is something you create with the blockchain. ASAs is another name for them. And ecosystem for token holders is what they provide. And there is a video on that available if you want to see more information on that as well. Now, the next one here is Circle and Coinbase. It's a central consortium and payments and treasury infrastructure for the internet. It accepts payments. You can send out globally, leverage traditional payments through blockchain infrastructure, as well as it's global, scalable, and efficient. This is all about USDC, which is the fastest growing stablecoin. 2.3 billion was a few months ago. I'm sure it's far greater than that at this point as well. So those that aren't familiar with USDC, one of the problems with cryptocurrency like Bitcoin or even our algo that Algorand has on our chain is that those tend to fluctuate sometimes. They'll go way up or way down. And that's very difficult to do transactions in that kind of a scenario. Where a USDC token is tied to the USD economy. So if the US dollar goes up and down, so does that particular token. So this makes it a lot more attractive for investors and people to spend money and do transactions, knowing that it is going to be fairly more stable. So that's a good thing. And we have a case study on that up on our case study site. Just go to algorand.com, use case studies. Also, I recently read a crypto thesis for 2021 at Mazario.io. You can see the reference at the bottom there. And this was referenced in the document. That's a great read, by the way. If you're really looking to bone up on all the acronyms and technology and everything, download that report. It's free. I think you just got to sign up on the site and you can get the PDF. It's, like I said, it's about 130 pages. So with that in mind and creating assets, in the old days, a lot of companies used to do stock options or some way to share the equity of the company and wealth with its employees. And this idea is a great idea, right? Because then the employees really get incentive to do well and get more rewards, get more ownership in the company. Well, now with blockchain assets, it really opens the door up. Think about these things and the possibilities of Wikipedia. What if Wikipedia was owned by the editors? You post an editor, do a post and do some editing, and then you get rewarded for that and by getting maybe a token for that. And all of these work along the same line. So it could be a small business that lists on Yelp, or the contributors help power it, own shares in the company. Could Reddit reward its moderators with ownership? Airbnb host equity if they become a superhost. Uber driver, like Uber the profits are like exponential, but the drivers are at a linear income. It's very straight and narrow. So these are things that make you think about the potential for these assets. So like Uber drivers could own a piece of the business if they maintain a high enough rating over rides, for example. So these are all things that would help out. And then, if you take a look at some more things, other use cases here, basically what we see here is tamper-proof charity organization. Now, this information I got from the China blockchain report for 2020. And for example, when there was a big earthquake out there about 10 years ago, there was really a misuse of funds on the charity collections. There was no track record. There was no accounting or no ledger that was easily accessible and can see where the information was coming from and going to. So really what they're doing is looking at improving transparency of all social services. And something like blockchain, when I get into the blockchain section, is ideally, it is tamper-proof. And that's one of the biggest strengths of it. And it does have an audit trail built right in as such. So that is a very strong feature of blockchain type solutions. And this way facilitates tracking of the donations and having that audit trail. And what about voting? Another great solution. This is seeing how it's tamper-proof. There's no ifs, ands, or buts about any kind of voting that's going on. Another great solution for a blockchain to facilitate. And it doesn't end there. Healthcare with global access and medical records. I can't tell you how many times I go to a new doctor, then I got to spend a half hour updating all my medical records with this doctor. Wouldn't it be nice if I can control my own medical records and say, okay, here it is. It's out on a blockchain. This is all the information that you need. And boom, I'm done and don't have to worry about that. But more than just a convenience, what if you're not able to provide that information? Maybe it's an emergency and you can't talk or not capable of it. These are all things you have to consider, and these are problems that today we're facing in the healthcare industry by not having the stuff globally accessed. You need to have it at where the medical team is really where you need to have that information. Automotive, another big area. Supply chain visit, any kind of supply chain type application is a great solution where you got checkoffs along the way. So a lot of effort is going into, for example, what China is doing is putting sensors into the engines, and anytime maintenance is done, it automatically tracks it and puts it out on the blockchain, so they know definitively what wear and tear that particular automobile has been through. And so again, these are all different industries that can utilize this going forward. This all goes to the spare parts and really writing that data generally right to the blockchain. But you know what? The biggest area that's most exciting is DeFi, and that stands for Distributed Finance. This is exploding in the 20 and 21 years. And again, I got these figures right from that Mazzario report. And believe it or not, in 2020, $1 trillion in cumulative blockchain network value. So there's a lot of blockchains out there. There's Bitcoin, there's Ethereum, there's Algorand, and about 1,900 other blockchains last time I checked. The cumulative value of all those networks is over $1 trillion. And most of that was done in the last 6 months of the year. So this is something that is pretty exciting, and the forecast is threefold. This coming year in 2021, expecting over $3 trillion are forecast in the blockchain industry. That, my friends, is nothing to sneeze at. That is a significant hit in terms of the usage for blockchain. And you'll see that part of the reason for this is the fact that there are no boundaries, like when you're doing transactions. One of the beautiful things about blockchain is the fact that there's 2 billion people on this planet that lack access to modern financial services. And you don't need modern financial services to do blockchain transactions. All you need is a sender and a receiver. There's no middleman. So this really facilitates financial transactions really good. And this is why you're seeing this take off. So a few other reasons we'll hit upon too, but those are the main ones. In the case of Algorand, really great performance. So a lot of these folks are hopping on board with IDEX, Polkadot, stablecoins like Tether. We mentioned USDC, MELD. These are all examples of DeFi applications that are running on our network. and more use cases as well. We even got World Chess on board, as well as things like Planet Watch, Republic. These are all folks that are utilizing our blockchain, and you just go out to the use cases site linked up on top. And then finally, this is an amazing slide. We've been around for 2 years, and we've got over 500 companies that leverage the Algorand blockchain performance, and over 60 global exchanges we're on. You'll see Algos listed there. 70 asset issuers. So this are building your assets, or stablecoins is an example of that. We are one of only 2 blockchains with the top 2 stablecoins, USDC and USDT. And there's reasons for this, and we'll go to a few of those when we go over the protocol in the next section. Also, very big in the community. We had over 500 ambassadors. These are like our MVPs representing 60 countries as well. So you can see a lot of universities engaged, financial infrastructure, a lot of technical groups. It's really going good. Then the last slide here in this section, these are like a few of these quotes. The one in the upper left I like in particular. It's about the documentation, so that's a nice quote. And so on the upper right, you've got the transaction fees are minimal, like 1/20th of a cent. And then also the speed to ensure users won't get caught up in the slow or delayed transactions that dominate so much of the current digital asset landscape. Also, performance and capabilities are unmatched with Republic, and down in there, Palumi says all other blockchain platforms, transaction costs are very expensive and speed is painfully slow. And he feels that Algorand is a game changer. So that's just a little bit to get your interest up a little bit. Now let's get into the blockchain. For everybody that's brand new, basically this represents a blockchain, and the way you can think of this is a ledger. We have one block, and it's a read-only ledger, except for when you go to write a new block, and a block has associated transactions with it. Some of you may have heard of forks or proof of work. In other words, mining, for example, that's done with Bitcoin. And this, we don't do any of that. And we basically do this. Okay. So what we do is we use the Byzantine generals problem to kind of describe this, right? So those that are unfamiliar with this, back in the day, you would have maybe 20 generals around this empire, and they have to communicate in order to figure if they're going to attack or not. And so if they have to communicate things like, do we have the supplies? Do we have enough people? Is anybody sick? That sort of thing. And they sent messengers around to each general to inform them. But something can happen to those messengers. They can break a leg and not get there. They can be corrupted. They can just not go because it's raining out or whatever. And so there's a problem there. And it's tough to reach a consensus when you don't have everyone that's participating in it. And so the problem here is that the cost of this grows exponentially, or even quadratically, when you start scaling up the number of folks that have to communicate to create a census. And when you get to maybe a million, say, folks, it's a million squared is the cost. And so what happened here is that Silvio Macaulay, our founder, figured it out. You don't really need everyone to participate. What you need is a representative sample, and the representative sample is key, and that's part of our VRF, or the verifiable random function. And Silvio is also a Turing Award winner, and for those new to the computing field, that's a very coveted award, like a Grammy in the entertainment industry. So we're pretty fortunate to have him as a founder of the company, and a lot of his smarts went into the protocol that we build. So this is the key idea behind it. A small random number of committee members are used, and then at that point the committee agrees on a block of transaction, and every member verifies the transactions and digitally signs it. So this part of the process also includes verifying that the funds are there, right, in the sending account, that they're not double spending and that sort of thing. So that what goes into the voting process, and then the vote is added to the chain. And then you rinse and repeat. You do this again. This is done every 4 or 5 seconds is when these blocks are created, as opposed to Ethereum or the Bitcoin, where it's like minutes, like several minutes, 10 minutes. So by having a blockchain like this, it really facilitates point of sales transactions a lot easier, as well as just really transactions in general. So you can learn more about this protocol by watching a video up there, but hopefully this made sense in terms of really just think about a blockchain as a distributed ledger, and everybody's got a copy. You run a node, you got a copy of that data store right on your machine. And that's the idea. It is distributed, it's open, and it is available for really anyone to participate, which gets us to these two slides. Permissioned versus permissionless, and private versus public. We hear this a lot in the industry when folks are talking about blockchain. So a private blockchain is a permissioned blockchain, and a public blockchain is a permissionless blockchain. In other words, anyone can join in a public blockchain. Anyone can read, anybody can write to that one block that's being burned, and it's decentralized. No one has control over the network. It's secure, and the data cannot be changed once it is validated. And the reason for that, it's like a hashing algorithm that is used between each block. So it's very easily to detect any tampering in the blockchain. So this is a very good feature. And once that's done, you're off to the races. I had a woman that was in one of my sessions. I did a presentation in Tampa to the Women Who Code group, and she was in cybersecurity. And the way she explained it was, in terms of security, is the fact that Algorand it's like a two-factor authentication where you have to verify that this is you by accepting a text message on your phone or an email or something like that. This is something that I think that she said is multiplying that times the number of blocks in the blockchain. That's how secure it is. So if that makes sense, that's really what's going on here, because you have that layer of security building all the way back to the Genesis block. Now, the private blockchain, this allows selected transactions, and authentication is typically required as it's built into the blockchain in terms of providing restrictions on who is allowed to participate in the network. So now you're probably asking, gee, what kind of applications can I build on a public and open blockchain like Algorand? Am I only limited to public and open? Well, no. And I'll get to all of these categories, but the short story is you can create solutions for all of these. But the ones for that I will start with here is like public and open. So ideal for currencies, ideal for betting, video games thing, where it really is, there's no need to be not open, right? You're all set. You can do this kind of stuff there. With public and closed, maybe you want a portion of this to be public. Maybe you want the voting records withheld until a certain time, till all the voting is done, and then you could release that information. So it's both public and closed. Down in the bottom right, you got private and open. So this might be supply chain, where it might be you've got government financial records or corporate existing earnings, where you do want to release the earnings at some point, but you private while you're creating them. And then finally, private and closed on the bottom left, things like national defense, law enforcement, military, tax returns. So here's the deal. What you can do is create a layer 2 solution that provides the authentication to the blockchain itself. So if you have an application, then your developers would be responsible for building that authentication piece. And there's actually partners that are available on our site that have products that do just that, and you could utilize that going forward. We have a note field on transaction that's free form, so you can put any kind of data structure you want in there. Some folks use it to maybe point to IPFS, which is a distributed data store. And those two go hand in hand with like Algorand's technology for distributed blockchain. So if you had like assets, videos or something like that, maybe you'd store them on IPFS, and then you put a link to them on the blockchain through the note field, perhaps. Okay, let's get into layer 1 features. All right, so this is right on the blockchain itself, and we're going to talk about a few things here. One of them is called Algorand standard assets. Then we got atomic transactions, smart contracts, and Rekeying. We're going to cover these 4 topics in this section. What are these? First, we'll start out with the pure proof of stake protocol. That's what it's called, and it is pretty cool. It offers true scalability, and we have pegged it at over 1,000 transactions per second, less than 5 seconds to burn a block, and this is getting better even. So it's getting faster, and we're getting more throughput on this as well. And then also infrastructure longevity. We've rolled out several updates to the blockchain, smooth as silk. And then technical flexibility. We've got all sorts of SDKs. We offer up REST APIs, a lot of great tools. Transaction certainty. There's no forking. I didn't talk about this on other blockchains like Bitcoin. The miners will be spending a lot of money, first of all, because it's not green. They have to have very expensive equipment to burn a block. And sometimes when there's competing miners, you end up getting a fork. And only one of those forks will win and write the block to chain. Now you've got an orphaned fork. And so when you do a transaction, it's going to get done on our blockchain with the transaction certainty. Also, very extensible platform, a lot of great tools, command line tools, a lot of community tools have been built, as well as it's energy efficient. It's very lean and mean and green. You can actually run a node on a Raspberry Pi. So now you can envision expanding IoT to blockchain, where you have sensors writing data directly to the blockchain by having a node right there. It's very cost efficient as well, less than a penny for a transaction. And that's a really big attraction for a lot of these folks coming to the Algorand blockchain, as well as providing true security, as I mentioned, being a read-only data store. So with that said, let's talk about Algorand standard assets, or ASA. This facilitates you to create native tokens. You can create your own cryptocurrency with this capability, or you can create things like game tokens for a game. And this means also that there are several functions and management functions available to it. Asset spam protection, for example. And also you got to opt in to receive an asset. You can't just go ahead and send it blindly to everybody. And this resides on layer 1. This is built right into the protocols. What are some examples? Well, you got fungible tokens, which are basically each one of these is exactly the same. Each in-game point is the same. Each stable coin is worth the same amount. Loyalty points, system credits, these all fall into that category. And then you get restricted fungible tokens, where you can also invoke things like clawback if you need to under certain situations. Now, the other type of example is non-fungible tokens. And the way I like to think about this is, for example, in real estate, you can have a 2-bedroom house on one block, then go a few blocks over and you have a same kind of house, but it's worth different because there's other characteristics that are associated with it. So yes, they're the same, but they're different. You know what I mean? So that is how I like to think of this in terms of non-fungible. Things like certifications, collectibles, and then real estate could fall under the restricted, as well as ownership registries and regulatory certifications. All right, so let's take a look at our first demo. This is going to be AlgoDesk, and AlgoDesk is a visual way to create these assets. They also have an application manager for doing smart contracts, and we'll talk more about that in a little bit. I'm just going to focus on the creating of assets here. So the first thing you want to do is copy these phrases off. Anytime you create an account, this is actually referred to as a secret key, sometimes a spending key. And what this is going to be associated with is your ability to sign off on a transaction. If you want to send assets or algos from your account to another account, then this is what facilitates you to do that. And this is what would be used to restore your account if you ever wanted to restore it and have that available. So that is very important. And typically there are things called a ledger, like a nano ledger. I got one here in my hand. It looks like a USB stick, but it's not. It doesn't connect to your machine at all or the internet. And so that's a very good way to store that kind of information is on those. And it hooks up with Bluetooth, maybe with a wallet app like your Algorand wallet, and you can use the two in combination with each other. So anyway, that's a little bit of background. I'll talk more about public and private keys in a little bit. So this is the asset. We're going to go ahead and create one. This is our account we're working with there on top. And I am going to create one here called Pizza REF. We'll go with my name. And this one here, we'll just go with a unit of PRUS2. And then I've got an asset URL. So there is a URL field, by the way. So if you didn't want to use the note field to put the URL for IPFS, for example, you can have it as a field on this particular asset. And then these are the roles we started talking about. You have a reserve address role, which is it manages your reserves. Clawback is in charge of getting funds back. Freezing an account, you have a different role there, and then a manager role, as well as the creator that's creating this right now. So how many do we want to create of these? So let's create 1,000, maybe 100,000 of these over here. And then how many decimals do we want? And let's go with 1 decimal. So right now that would be 1,000,000.1. All right, is what we got there. So let's go ahead and create that. Now, if we go down to the bottom, we should see it down here, right over here. There's the pizza wrap, and there you can see the different roles that are assigned to, they're all assigned to the same users. Now you've got the ability to send this asset to somebody, to modify the asset. So in other words, you can change the roles here. You got freezing, unfreezing, revoking, and all those functions. Also, this other link here will bring us out to a browser. So this is one of the first browsers we will show you here. And this browser will look at asset IDs. So it takes that asset, brings it up here. Here is the total supply. It tells you how many are in circulation. It gives you the creator address, the reserve address. There's a transaction here that created it. You can click on the transaction ID. It'll give you the time when it was done, who it was done from and to as well. It's a lot of great information there. There's one more browser to show you as well, and that would be the browser for Goal Seeker, and very similar as well. And you have the ability to look at blocks, asset transactions. They also have a developer portal. This is done by PureStake.io. We'll talk more about them. And the other one that was done was by Rand Labs, and they also have API services too. So we'll go ahead and take a look at that once again. And also you have the different networks that are available to you: mainnet, testnet, betanet. And mainnet also displays the current value of the algo right there. So it's a little over $1 right now. Just about 4 weeks ago, it was around about 25 cents, I think. So this whole industry is really going on the upward trend, all right, is what we're seeing there. So pretty cool things there are happening. Now let's go back over to the deck here. And the next thing I want to show you here is AlgoSigner. This is like a Chrome-based wallet, and it's in the Chrome web store. Here's the link for it right there. And the way it works is this. You actually have the ability now to integrate with this wallet with your solutions or applications you're building. So I've got a couple of things added into my wallet here. And let's go ahead and click on Pizza Demo. And I can see here I've got Pizza Rust. I can add a new asset. I can view here. Let's go into Pizza Rust. Again, I forget what I called it last time, but it would be there. You get the idea. And you notice that there's two, that these are the same name, and you can also have the same unit name. The only thing that's unique about an asset is this, the asset ID that you see on the right-hand side. That is how you confirm that you're getting the right asset of someone that's sending it to you, saying, okay, they'll give you instructions, look for this particular asset ID to opt in. And so you can actually do transactions. So let's go ahead and do one here. We'll go ahead and send some algos. I'm going to go back over here from my Rust account. Let's go ahead and send 1 algo. And algos are to the six decimals. So 1 algo is equal to 1,000,000 micro algos. And so I'm going to go to, I'll paste an address here. You can put a note in the note field, and then we can go ahead and send it. And all right, and there's the transaction ID. So I can copy that off, for example. Go back to the account. Now I can see that list of transactions in my account right here in the wallet. And then once again, we have like a community page with a lot of great stuff. This is our developer portal we're looking at. Let's go ahead and get back over to the deck. That kind of gave you the idea of a few cool tools right off the bat. And again, these are community members that made these, the AlgoDesk and AlgoSigner both. So pretty cool stuff there. Also, Algorand Atomic Transfers is next. I used to be a DBA at one point in my career. Don't tell anybody, but yeah, I was a DBA at one point, managing some large databases. Actually, I was back when I was at Aetna Life and Casualty. And there comes a time when you need to have referred to as a transaction in SQL database. Those are familiar with SQL. It could be several steps, and either all of those steps succeed or everything gets rolled back in the database to the way it was before that started. And atomic transfers is the same concept. All must succeed or all will fail. This is extremely useful. This is the secret sauce behind a lot of transactions that are done on the blockchain. It's a native function. Once again, layer 1, it's easy and secure, and you can wrap up to 16 transactions into one atomic transfer. This guarantees an exchange of goods. So in the example on the right, if person A sends 50 algos to person B, they're expecting to get a concert ticket back. So person B is going to send the concert ticket. If all of this happens, none of this happens. All right. So if only 50 gets sent to person B and B doesn't send the concert ticket, that 50 algos never got sent from person A. So that's exactly how to do it. But the real benefit of this is you can combine this with other Algorand technology. So those assets I just showed you, you can do a transaction on an asset from one person to another in exchange for another transaction and wrap that maybe in a smart contract. So a lot of things can be done with this to really make it some pretty cool things. All right, so examples for atomic transfers might be simplified expedited settlement, efficient matched funding, reduced counterparty risk, enable any multilateral trade as well as circular trades and group payments. And you can combine these with ASA or smart contracts, which we'll talk about next. It's a settlement for complex and multi-party transaction and distributed payments. So we have smart contracts. The language it's done is called TEAL. It stands for Transaction Execution Approval Language. It's like an assembler language. And you think about it, this has got to be very performant. And there's nothing more performant than that type of a language. It gets very expensive to host VMs on a blockchain. And that's part of the problems we've had in the past with other blockchains is the performance, right? Really gets bogged down with that approach. There is also a Python-enabled compiler called PyTeal that you can write it in Python and then use a compiler and it will generate the teal for you. And there's another tool I'm going to show at the end, which is AlgoDEA, and it has a lot of tools as well for generating templates and things of that nature in teal. There's two types of smart contracts. One of them is stateless and the other one's stateful. So the stateless is great for approving spending transactions, and stateful also facilitates global storage on the blockchain as well as local storage at the account level. So it's combinable with other Algorand technologies, with atomic transfers, Algorand assets. You can even combine stateless and stateful contracts together. So the smart contract value in the financial industry, allowing you to do trade finance, provides clearing and settlement capabilities, financial data recording, you got a digital identity. And then in DeFi, like we talked about up front, escrow accounts, managing payments, lending and credit, and stablecoins are very huge. So these are all things that this facilitates. Algorand accounts, let's talk about this now. There's three types. There's a standalone account, a multi-sig account, or multi-signature is what that stands for, and a logic account, which is what's facilitated with smart contracts. So you see the little keys on there. There's a public and a private key on the standard account. And then the multi-signature account requires a threshold out of a group of accounts. You define whatever the threshold is for that group. Say you have 5 in a group and you want 3 to be the threshold. So 3 of the accounts in that multi-signature account need to sign it. And then once the threshold is met, then it'll be approved. That's how that works. It's very analogous to you take a check to the bank, and sometimes checks require 2 signatures on it. Same type of thing. You got to have at least 2 signatures. In that case, a threshold would be true for them to cash that check. And then you have what's called an LSIG sometimes, or a logic SIG account, which the logic of a teal app returns true or false. So if it returns true, it'll sign it. If it returns false, it won't. And that's how that works. Rekeying is also a very important thing. Let's talk about public and private keys. First of all, a public key, you want everybody to have that. That's how you're going to get money. you're going to be able to say, okay, send me some money or assets or algos. Here's my public key. But the private key, on the other hand, is the one you want to put on your device, here, your Nano, or you want to put it on paper or stick it in your safety deposit box or whatever. You do not want those on your computer. You do not want those in email. You don't want those accessible to the internet, period. What do you do if you have to change the private key? So that's what the public and private key is all about. It's a cryptographic key pair. So on the left, you can see they're tied together, the public and the private key. So rekeying separates this process by assigning others that would be authorized to approve transactions. So there's another account that would be able to sign off on it, basically. So the middle diagram separates those two keys. Now this is useful because sometimes you're growing and first in your organization, and first you start out with a single signature, a single account. Now maybe you get a board of directors and you want to expand that to a multi-signature account. Well, until this feature came out, which is fairly recent, we had it a few months ago, came out, that was difficult to do. You had to basically recreate another account, recreate another set of private keys, and it was a mess. So now you have the ability to do that, and you can see the authorized field there on the upper right, authorized address field, now is wired into that standard account for the spending key. All right, so that's the intro on accounts and signing and rekeying. What I want to do is I got a couple scenarios here on solutions. And remember I said we can combine a lot of these features on layer one. Let's take a look at a voting example. And we have these solutions written up on our developer portal. You have a voting commission account with a spending token you want to get. And then these are going to be all atomically grouped, right? So all of this works or none of this does. Then you vote for candidate day A, and then there's a voting smart contract that makes sure that this thing is legit. And once it's a legit, it'll increment candidate vote total up on global state on the blockchain. So that's the whole scenario right there. So if for some reason the contract doesn't work, then this vote never happened. And then you would go back and make that happen. Crowdfunding, another popular solution for blockchain, and this is really becoming, I think, the de facto standard for crowdfunding type scenarios. You have crowdfunding escrow account with a stateless smart contract going to a payment for a user. Once again, these are all atomically grouped. And then user one claims the escrow funds once that escrow fundraising has been met. And the smart contract would be a stateful one that might determine that down below, and a stateless one up on top. Algorand Inc., who Ryan and I work for. And then there's the Algorand Foundation, which is responsible for token economics. And so anything with token distribution is the responsibility of the Algorand Foundation. I'll be going through some of the grant programs and things like that they have available toward the end, but there's a lot of really great routes for folks to, especially developers, to get on board and get a little extra cash for yourself as well in the process. Algorand developer tools. We've got a great developer portal. In fact, hot off the press, we just won this. We won a Debbie Award from Developer Week for Best Innovation in Blockchain, specifically for the developer portal. And so it just goes to show you we're being recognized now in the industry, and lots of great documentation out there. We've got a lot of feature guides, how to install and run nodes, a lot of great reference documentation. Let's just take a quick peek. All right, so this is and we even have a new metrics button here we just added. So you can see all the transactions per second, the addresses, the blocks, how many different assets are out there, and some really cool graphs and charts. So you can see really everything that's going on there. Then we've got some really great documentation. I want to point you to this to get started. You just go to Start Building, and we'll give you the lay of the land here in terms of setting up your environment. And then also connecting to a node, and I'll talk more about the connecting to a node as well. But basically, these first three steps is what you want to do. And by the time you're doing the third step, you're actually doing a transaction through one of our SDKs. Each one of these has different languages like Go, Java, Python, JavaScript samples are all in these tabs, as well as at the bottom, typically there is an example for a link to the code, and you can see all the samples right there as well. So that is, and then we get to building applications. This is starting to cover more of the smart contract stuff. And so really good to go through this as well. Feature guide, for example, you want to look at creating an account. These are the creation methods. There's a way to create like a standalone account, for example, here programmatically. I'll actually show you that in the demo. And then we got assets, atomic transfer, smart contracts, how you do each of these. We also have an indexer, which is good for searching the blockchain. And then tutorials, a lot of great tutorials out there. I actually did some on using VS Code with JavaScript and C# and Go and Java, for example. And there's a lot of ones around building assets. These all are step by step. So here's one right here on Algorand Builder. That's another great tool from the community. In fact, we just did a developer office hours last week on that. We run those every other week on Tuesday, and I'll give you the link on that too as well. You're welcome to join. I just did one yesterday on Indexer, and next week we got one on AlgoDEA, which is the last demo today. Very cool stuff. So anyway, I like the hard hat. Anybody knows me from before, I used to be Russ of Russ's Tool Shed for Microsoft, so I always dressed like that, so I like that. But anyway, these are all step-by-step. So there you can see the sort by language as well as the level. So some good things there. All right, if you want to contribute, there's a button there. We have more and more community members. Bello here, he's been out in the community doing a lot of great stuff. This is by Robert. He actually did the session last week for us too on Algorand Builder. He wrote it. So a lot of great content. Also, in addition to tutorials, we have solutions. There you can see that. And also we got some great articles, just pieces of information that are very fruitful, and the forums to go out to. So this is the lay of the land for the developer portal. So we have three networks. One is mainnet. That's production. TestNet is a mirror of that. And there's also BetaNet that we use for rolling out new releases. And there's a private network that you can run, which is private to your own machine. I like to refer to that as a personal network. I like to use a personal network when we're going through rapid changes in BetaNet. So I like to create basically a copy of that BetaNet, keep it on mine so no more changes are done, and I could do my testing in BetaNet until I'm ready to move on to the next testing suite. And then BetaNet also is really all about the newest protocol level features. So whenever we do an update to the protocol, that's where we test it out first. TestNet and mainnet get rolled out at the same time. The idea is that if it works in TestNet, it'll work in mainnet. So it's the exact same protocol in each of those environments. And then once you get started setting up your node, you've got the ability to create nodes on a Mac. You've been to other Linux distros, example, Raspberry Pi. You can actually do it on Windows now too. I got to update this slide. That was a community contribution to our blockchain. This used to take several hours to build your own now, but now there's another feature called Fast Catch-up. And within minutes, your node will be ready to go and you can start using it to do transactions. PureStake and Rand Labs do have API services. They're both indexed and archived. If you build your own indexer, we're going to talk about that, you cannot use fast catch-up. You have to use a completely archived node, which could take a while. But the moral of the story is here, you can access these from the SDK code on platforms that do not have nodes. So I wrote, one of my tutorials was using Xamarin, and I built an iOS Android app solution. And so from that, you can access that code from those platforms. And I used examples in there for PureStake as well as the sandbox, which I'm going to talk about in a little bit as well. But that's a great example of maybe using PureStake or Rand Labs API service would be in a mobile app because you don't maybe have access to a server on your phone. So that's a great way to do it. Sandbox is excellent. This is a Docker instance. Typically, it's not used for production because you can reset it at any time. But basically, it's a snapshot, and there's really little sync time. And you can run this on Windows as well. So then we got, how do I get started right with Sandbox? Well, you install Docker, you clone the Sandbox. Now it defaults to the private network with Sandbox up. So it will go ahead and for testnet, you would do Sandbox up testnet, and you can do mainnet and betanet as well. Those are all supported. So we did a video. Ryan actually delivered this session up on YouTube. Our YouTube channel is youtube.com/Algorand. And this is a picture of the README file. what you need to do programming wise when you start using the SDKs is you need the address of a node and the token of that particular node. And that is how you get going. And the code you'll see in a minute utilizes that. And for Sandbox, it always goes to localhost 4001, all A's. KMD is another daemon we have. That's a wallet, like a cloud-based wallet. And then it's really good for testing wallet type scenarios. But I would use AlgoSigner for wallet interaction, as well as you got Indexer down below. So Indexer is very interesting. And so now you get that by default with Sandbox too. Covered that. And then we have 4 SDKs, like I mentioned, Go, Java, JavaScript, and Python. We also do have a C# SDK that just got upgraded and is current. Any Sharp devs out there, a few of you replied on that. How do you install an SDK? And we've got a really nice document here under our SDK reference guide. And for each language, it shows you what to do to run NPM there. This is a list to see what the current version is. And we got these client instantiations. How do you instantiate a client right here too? And this is for each language. Is right there. Get you going real easy once you install your SDK. We do have dispensers, right? So when you're running TestNet, you'll need to dispense funds to a newly created account. You can see that you will be able to dispense funds to cover things like transaction fees. And so these are dispensers that are available to do that. So let's take a look at our first coding demo here. We're going to create accounts and dispense funds to that account, and then we'll do our first transaction. So here is the solution. I'm just going to run it. I've got the breakpoints already set, and this is in our favorite language here tonight. These are all going to be in JavaScript. And so here we go. So now I hit it right there. So what I've done up above here is I have created and generated 3 accounts. And account 1, account 2, and account 3. And I printed off the information down below with the mnemonics as well as the addresses. So for example, what I would do is copy that address, and we're going to need that in a minute, but this is where I want to point to first. This is using the sandbox. So there you can see the token, the server. This instantiates the client. Now I'm off and running, so I've got client functions I could utilize, as well as functions from the SDK, which is brought in at the top here. So this AlgoDEA SDK, anything basically to do with secret keys and doesn't go across the wire would be using the SDK versus the client. And so, for example, to create an account which deals with secret keys, you'd be using the Algo SDK, and there's the secret key to mnemonic, and there's the secret key that is cryptic. And then, so I'm just going to continue running this straight through. Let's go out to the dispenser. So on the dispenser, we need to put some funds in there. This is how you do it. You just paste that address that we copied off. Now this account is ready to rock and roll. I can start sending algos in TestNet. So that's it. Very simple to do. So once you got your accounts created, let's go bring in the next one. All right, so let's do our first transaction. And once again, I'll hit the breakpoints I've got in here. And what I've done here is I have used the note field that we talked about. And the note field is right there. And I'm going to encode this hello world string on it. Then I'm going to make a payment. I'm going to send from the account here called my account to the receiver, which I got specified up here. Now this my account, you've got to have the spending key in order to do that. And the way you get that is you, in this case, these examples restore that passphrase we talked about, and that then creates the my account variable where you've got the secret key available to do the transactions. So there's the secret key right there in bytes. All right, so this is ready to go. We'll continue on here. We're going to make the payment next. And then we want to sign it with the secret key from the sender. And this step here is the important one, send raw transaction. This will broadcast it to the network. And what this does is we're going to wait for the confirmation on this. And once this confirms, we'll have the transaction ID come back, and there it is. Now it's just completed executing and running, and we can see that information down in the debug console as well. So this wait for confirmation is the guy that says, okay, do you have enough funds to cover this particular transaction? If you do, and you're not double spending in any other scenario like that, then it'll go ahead and it'll get approved and written out to the blockchain. That's the sequence. Every time you do a transaction, what you want to do is you want to make the payment transaction itself, then you want to sign it right here, and then you want to do a send to the network. So those are the 3 steps that you would need to code this up. So it's not too bad. We got a transaction here with 100 lines of code pretty much that does that. All right, let's get back out to the next demo is going to be multi-sig transactions. So let's show you that. All right, so the first part of this, we've restored 3 accounts. So we've got 3 accounts restored. And what we want to do here is set up our multi-sig account. And the multi-sig account is going to consist of all 3 of those. And what we're saying is we want a threshold of 2 on that. And then there's a version number that's associated. So any 2 of these that sign off and then you broadcast it will be written to the blockchain. So the next step is to take and get that multi-sig address. So we're going to create the multi-sig address from those parms. Let's just step over that and we can write that out to the console, which is down below. So here it is, multi-sig address. So what you want to do is make sure that account is funded. And it will be the same every time if this is done in the same order, right? The same threshold, the same addresses in that order. And then because what's going to happen is the multi-sig address is going to be the one that's going to be sending the funds out. Then what we'll do is the same thing. Then we'll go ahead and these are transaction parms that we use in on the calls. And you can see those get passed in as a parameter over here on the right. And you can see things like the first round, the last round, it's got to be within a 1,000 round range. You've got the Genesis ID, you're working on TestNet, and the fee, if there's any fees that are incorporated. So or if it's a flat fee or not. So let's go ahead and set the flat fee up, and that is now set. So if I hover that, now it's been set. So we got flat fee equals true, and we got 1,000 is a flat fee. Now we're going to do the same thing with the hello world, and the rest of it is actually the same, except that what we're going to do is we're going to do a couple signings, right? The first one is going to be account 1, and then we're going to append to that transaction the signing from account 2, which is right here. And you can see this is the append multisig transaction. So now we got both of them signed off, and the send raw transaction will say, okay, does this all make sense? It does. Then it's going to go ahead and fire that off and write that to the blockchain. And that is where we are done with that. Okay, so there it is. It all fired up where we're going to send the raw transaction now. And then this will go ahead and write it out to the blockchain. So that is a multisig example. And then atomic transactions will be next. Let's go show you atomic transfers. So we're going to recover 3 accounts. And there we have 2 transactions that we're signing. So what we want to do here is we want to send from account A to this receiver account, which begins with GD, 1 algo. And also we want to send from B, account B, an algo. And we want to have both of these succeed. So we're combining both of these transactions into a transaction group and get the group, both of those transactions by getting the group ID. And the group ID is what's used in the transaction. And then we'll go ahead and sign both of those. And then once that's done, we get down to over here, which is where we're going to send the raw transaction. And that goes out to the network. So that's how you accommodate atomic transfers, by saying, okay, the first one's got to work and the second one's got to work, and then we're good to go. So moving on to a very interesting area now are smart contracts. So the stateless version of these replaces the signing of transactions. So just like we had accounts sign transactions or a multi-sig account sign a transaction, now a logic account, if it returns true, will be able to sign a transaction. So a logic account is any transaction sent from this account will be verified by the predefined logic. This is typically good for things like escrow accounts, payments, split payments. Hash time lock contracts is another good example. The logic signature, any transactions are signed with the signature will be verified predefined logic, or in other words, a delegated authority. So not only does the contract have to return true, but also it needs an account sign off as well. It needs both of those things. These are good for things like recurring payments. So I'm going to show you a couple things in this. Number one, I'm going to read in a sample teal program. And what we're going to do is compile that. So we're going to read it in. We're going to compile that program that we have in from our file that we read in. And once that's done, we're going to use that as an argument for the transaction later on. So right down below, you can see this is the hash or the address for that smart contract. And this is the contract address that you would need to populate with funds if you were going to be having it send based on a true value. Pass arguments in the smart contracts. Actually, this one is going to be calling sample teal arg. This is the one we're actually using. And it's just going to compare the argument that comes in if it's equal to this integer 1, 2, 3, 4, 5. So now what I'm going to do is let's go back over to that. I'll continue here. And I'm going to make a logic sig based off of the args that are passed in as well as the program. So there we're going to send 10,000 micro algos. We are not going to use a note field this time, and we're just going to have a sender, receiver, and an amount. And basically, now what we're going to do to sign it is use the sign logic sig transaction object here. And then we use the send raw transaction at the end. But that's the one that's used, the sign logic method in the Algos SDK is used to go ahead and sign that off. So now we'll go ahead and continue on here. And this was successful. It did a match. It matched what we were sending in as an argument as to what it is testing in the teal application. So that's it there on that one. And the delegated account will be very simple, and I'll show you that in a little bit. So let's talk about smart contract lifecycles. You get the ability to create an application, opt in or participate in local storage. No op is actually calling the application. And then you have update the application, delete the application, close out the application, and then clear state will always clear. And close out the teal logic must be true to close it out. So that's the life cycle. So all these can be done, and there's a good link there to do that. When it comes to debugging, basically what we do for debugging is you would wrap three things into a dry run request. One is account information, the signed transaction, and something that's called the approval program, and the program that's going to be running for the smart contract. Then what you do is there's a debugger called teal debug, and you would run that, and then you'd be able to debug it in Chrome inspect. Here you can see a screenshot of that. You can set breakpoints, step right through, see what's on the stack, and utilize that. I'm going to do an example now. Okay, so Bob wants to buy asset A, and he's willing to pay X algos per asset A. He wants to spend at least a minimum amount on algos and wants to spend no more than the max. So the solution is a stateless contract limit order to start with. And then the stateless contracts do not live on the blockchain. They must be supplied anytime the contract is needed. The problem is it's not discoverable, and it must be handled by a layer 2 app. This again, it's not on the blockchain. So you bake in logic into the stateless contract, require a call to the stateful app. So the stateless one is going to call the stateful one. That's the scenario. And does not solve the requirement to have the stateless logic, but it does make it discoverable because now that particular contract is on it. So let's go ahead and take a look at this demo. And once again, this is the architecture. We got a web app we're going to show you this time. It's going to write to storage. We got embedded stateless contract here as well. And then what we're going to do is invoke the stateful contract on the Algorand blockchain. So let's show you how this works. And we'll go over to this one here. So let's go ahead and run this. Okay, so what I want to do here, first and foremost, is I'm going to place an order. And now this is going to place an order. So you can see the asset ID I'm working with, the minimum amount we talked about, the maximum amount, and this is a ratio, and is the N units per asset per D micro algos. So you get 1 asset per 10,000 micro algos. So it's a 1/10,000th ratio. The order has been completed, comes up here. Now we're going to, if I were to place this order again, what's going to hit is the logic that gets rejected by the approval program. When you see an approval program, that's a stateful contract that is doing that logic. So I can't put another request in, so it catches that. Then what I'm going to do is refresh the orders. This is going to go up against index server and get a list of open orders. So I'm going to click on that one. And then if I, for example, we wanted to spend, say, 1 to 10,000. If I make this 20,000 right here and hit execute order, it's going to give me a teal runtime encountered error. Now this is being done by a stateless. Anytime you see a teal runtime error or specifically rejected by logic, like you saw, you didn't see it the last time, but if I had changed that number, that 1, 2, 3, 4, 5, and compared to something else, you would have got a rejected by logic message just like that. What I'm going to do is make this in the ratio that is requested. We're going to refresh the orders again, bring that up and execute that order. And now that's going to be a success. And then finally, if I did have any outstanding orders left, I can click on it here and close order, but that automatically took it off the queue. So let's take a look at some of the logic in this. So the first thing we'll take a look at is, let's go right down to the bottom of this. All right, so this was the open order method that we called, it gets called. So what we're going to do here is simply come down over here. This is the logic that interacts with the server. We got a PHP server running here on this one. Then what we're going to do is call a method here to make the logic sig right there. So now sign it with the logic signature on that particular account. So that is going to be done in this particular function for opening the orders. Now right above it is one for the opt-out. And we didn't talk about opt-in or opt-out, but you need to opt in and out, or you need to opt in to accept those assets. And this is the one we use to execute the order. And we went through this, and then we went to go ahead and do the logic SID from that particular routine, and this will go ahead and execute it. And then finally, these are all done. This is all done in Dex.js. This is all on the website. Now, this is behind the HTML, what's going on. And then this section here does a list on open orders. So this one here is actually going to search accounts using the indexer client. And so now this is going to search it for that particular application ID. And the application ID is what we had done in the stateful contract. And then if you look at this one, the next one here, if you look at the teal, does the stateful contract, this is basically what you see here. And if you hover over some of these things like type enum, it comes up with the tip. And I got that because under the extensions, there is an Algorand VS Code extension. Install that, and then you'll get the things that make more sense. And if you hover over any of these things that are in yellow, it'll give you a tip on one of those here in this browser. So this is where you have the number of arguments that are being passed. It's going to take 2 arguments. What action to do, right? Open, close, or execute. And then the order number is the second argument. So a test here for the first argument to see if it's open. If it is, you go to the open label or close or execute. So any of those would branch accordingly to like these labels right down here. So this would be used for open. So that's like a high level overview of this, but I wanted to give you more of a real world example that ties all these together. And so let's talk about index server next. Basically, this diagram says it all. You have an Algorand blockchain on the right. The AlgoDEA process is what's going to be accessed to build a database. The database is a PostgreSQL database. So it makes sense, right? You want to do robust queries, you get an actual database to do that against, not a blockchain. And so this will get populated as the node is running. These are all accessible from all of these SDKs on top, plus the C# SDK as well. And you can have different choices here. You can build your own. And we have documentation that points to do that. Very time consuming, probably take 4 days to get that built. You can use it as a service, both PureStake and Explorer.io have that. Or you can use a sandbox, which is the easiest way for developers, and use the default for private network, which includes an indexer indents. Also, you've got your own REST APIs with this. And for example, we've got a run in Postman here, for example, on indexer, as well as I got a run in Postman for V2, or you can do curl commands if you want to test that out, because with private network, you do not have the explorers like you do like with TestNet. So this is maybe how you might be doing your queries. So I'm going to bring up the Postman. It's spinning up right now. The account information is very robust. And if I bring this up full screen here, what you can see is everything that's in here. So this is actually a transaction that's coming back, and all the information that's associated with the transaction. On the account one, if I send this over, now you can see I've got assets that are associated with that account, and these are holdings. These people have opted in, and they have a balance of that particular asset. And so there's a bunch of these that might be associated with the account. Then also you've got created apps, which are the stateful apps that we looked at. And then we have created assets. So this is the creator account that created these. Remember, we saw all those addresses that were done with that AlgoDEA tool. So those are all the ones that are created, and there would be a similar one for just those that have opted into the apps. So that's the lay of the land there, and using one of the tools that's built right in for you there to do queries on Sandbox. All right, we also have the Algorand wallet, so you can download that from your App Store or Google Play. Nanolex ledger support, test and mainnet settings for developers. Rekey to do that ledger is available, and then you have asset support as well. I showed you the community page. There's a lot of great things on that, and all of these community projects I'm about to show you are fairly new and pretty cool. So Reach is the first one we're going to talk about. It's basically a blockchain agnostic tool, and you write it once with one set of code in JavaScript and Reach language, and then you could deploy it to both Ethereum and Algorand. And they're going to be going to more blockchains. Also, they just announced a couple of days ago they're going beyond JavaScript. They have support for Go, I think Java, and Rust was another one that they provided. It's got its own compiler and outputs to any chain. It's just a configuration change, and mathematically guarantees safety, outputs the entire application, not just a smart contract, and it deploys and runs simulation tests. Then there's the API for AlgoSigner. This is available to integrate with in JavaScript. So there's API calls right to the AlgoSigner that I showed. And this is the coolest thing, I think, right here is this AlgoDEA, and it's a IntelliJ plugin IDE. And it creates stateless and stateful contracts directly to the IDE. You got asset management, test account management. It's really great. We're doing a session on that on the 23rd at noon Eastern Standard Time. Make sure you sign up for that on our developer page. So let's take a look at these. The first one we'll show you is a very quick one. This is the AlgoSigner API. Here's the JavaScript on the right. So this just checks to see if it's installed. The plugin's installed. It says, yep, it's installed. Then we want to connect. We're going to use the AlgoSigner connect method here. And then they'll go ahead. Now I'm connected, and now let's get those accounts that are in my testnet environment. And there they are. They come back listed. And what's the status? Gives you back your block status. So these are all API calls that you have, and you can put in the Rust coin one here. Let's get 10 of these, and then look for those assets. And there's those assets come back. So pretty cool thing in terms of building solutions. Now let's go to Reach. So I've got two terminals opened up, and what I'm going to do is I'm going to fire up rock, paper, scissors games, and then we're going to look at the code that was used to build this. So are you Alice? Yes, I'm going to be Alice. Would you like to create an account? Yes. And this is going to be no over here. And we'll create an account for him too. And then now you want to deploy a contract over here. We're going to say, yes, I want to do it. I want to be, the contract is what guides the rules to the game. And so we're going to do that for Alice, but we're going to use that contract from Alice to play the game. That's the game, right? So we're going to say no here for Bob. Now, this is the contract, and this will look different if you're running for Algorand, which we are here, or Ethereum will be a different thing. And so now we're going to paste the contract information in there. And then how much do you want to wager? There's even a little betting going on here. And so we got 10. This is in micro algos, is what it says over here. And then it should ask for the move next once it does that. So it's going to go ahead. Do you accept the wager? Yes, I do. And we'll come back over here to Alice, and we'll go ahead and play the game. All right, so let's do rock. Let's do rock over here. And let's do paper here. So I'm not sure if we'll take it there with the backspace. We'll find out. Oh, there it is. We're going to play paper. I guess it doesn't. Backspace doesn't work in this game. All right, so now it's going to calculate and see one. And of course, paper covers rock. So we all know this game. And we're expecting Bob to win. And so that'll come back momentarily, and we'll see that on the bottom. There it is. So Bob wins, and there's the balances that are displayed. So let's go ahead and talk about the code here, first of all. So when we look here, is you've got this, this is the reach file. And it starts out with identifying the reach program on top. And then if we go down to line 39, we see the export statement there. And that the line defines the main export for the program. So when you compile this, that's what the compiler will look like. And then on line 42, you got the participants, Alice and Bob, that we're defining. And line 43 binds A and B to those participants. And we use that in the code. And the shell is similar for JavaScript. So now we can see the JavaScript method here that kicks in. And up on the top, let's take a look right from the top. There's on line 1 is the library it's going to load in. Then line 2 has the backend. So basically, you're referencing the backend that was built from the compilation. And this is the front end, is the way you can look at it in the JavaScript. All right. So this is going to have all the prompts in it, is the JavaScript. And then line 6 is the standard library that is used to load right there based on the reach connector mode environment variable. And then lines 7 through 47 are all the prompts. Line 21 in there does the new account test with the amount for that particular account. And 36 is the line here that deploys it to the back end onto the blockchain. And then we get the contract info right here. And then that's the string that got displayed we saw when we were playing the game that we had to copy over. And 48 then defines gets the balance, right, for that account. And you're off and running. Now, how do you make this deploy over to Ethereum? All you got to do is go down, and right now, this line here, 59, has a default app. And that is going, that's going to Algo. That's going to Algorand. All I got to do is cut that from that line and go up to line 32, I think it is, right here. And you can see this is the ETH. And you would just paste it right there. That's all you got to do is one setting change, and then you can run this exact application to go to Ethereum. All right, the final demo of the evening, just on time, is going to be AlgoDEA. And this is the local SDK. So these are the binaries you download when you do a node. You can specify nodes. You just add a new node right there. You specify the token and the server name, and then you have that accessible. So you can do different nodes here for TestNet, mainnet, PureStake, local, all those. If you right mouse click on here, you go to Algorand tab for accounts. Remember we did that create accounts with code. Now you got an IDE to do it, and you could do create a new account. Let's give it a name, blah, and then hit OK. And then here's your mnemonic, right? And your address. How easy is that? Then you would just take this address, once again, copy it off and go dispense funds. The other thing, which is very nice here now, is, for example, say I want to add in a teal program. I right mouse click, I do new teal. And now you got choices, right? You could do dynamic fees. These are templates, right? So let's look at an order template, limit order template. We got to give it a name. And now this gives you teal ready to go. This also supports PyTeal. If I have a PyTeal, I can do a new PyTeal, and it'll give you some choices there. This is the PyTeal that I created. So now I can right mouse click on that, and I can go and then compile that PyTeal, and it would then go ahead and generate the teal from that. Then let's take a look at this application. So what we're going to do now is create a stateless delegate. So this is a contract similar to the contract account that we did, but we're going to do it all visually here. There's a little bit of code that we have in this teal file. So we're going to test the receiver, compare it to our list in our list. If I go to Algorand accounts and list, it'll list all the accounts that we have. And then if you want to see what the balances are, if you're not sure if you populated it or not, like the last one's not populated, it's got 0. We would have to go populate that and see that. What we're testing for is a transaction from Bob. Bob begins with WCM, and that's the one we're going to be testing for. So let's build this thing up. So what I'm going to do here is do a stateless contract, and we're going to generate a logic sig, okay, on that code. So now what you'll see is the ability here to create a contract like we did, but we're going to use delegated. And the one we're going to have signed is going to be Alice. She's going to be sending it. And then we hit OK here. So now what you notice down below, there's the hash. So this is the account. They get the smart contract account. This is the one who's signing it, which is Alice, and you get other information here that was successfully. So we got a logic sig. Now I'm going to take this logic sig that it's just created up here, and let's send a transaction. So the first transaction I'm going to try here, this is so nice. This has got everything in here. You don't have to remember anything. I'm going to go to Rust demo instead of Bob, and let's see if this thing works. So we're going to do this. We're going to hit, let's transfer 10 and hit OK. And then what we'll down see here on the right is that this failed. Come right over here to the end. Get rid of these notifications. You can see rejected by logic. That's what we were expecting. Same thing. Let's try it again now. Let's send a transaction. And let's go legit. We're going to go to Bob. And again, if I was to put more than 10 algos, it would fail. Just put 10. You can also create your dry run here. We talked about that for debugging. Export a SignTX as well, or export the transaction as well, because that could all be used for debugging. So now let's go ahead and hit that, and it was successfully sent. It's pending going to the network, and then we should see a success right there. Contract successfully done. So that, folks, is the show. Let's bring back the deck and just go through some resources, and we'll draw our winner for the giveaway for the gift card. And stick around. I want to make sure if you win that I got your correct email, that you entered the correct email address. All right. I talked about foundation reward programs. There are several. There's a developer rewards program and a developer ambassador rewards program. For DevAms, if you submit a tutorial or an article to our site, you'll be part of that program. Then also there's ambassador reward programs for folks that like organize meetups, that sort of thing, do things in the community. There's grant programs if you have a large project in mind, and this is the list of the grant recipients. Look at all these ambassadors. We got over 500 ambassadors now in 66 countries. Quite a community out there. If you're interested in becoming one, give an email to Stephen at Algorand Foundation or visit community.algorand.org. Some great resources on teal. There's a good video Brian did and our engineering team, also the proof of stake protocol. These are all in the deck. I'll have a link for the deck in a minute. Where's all the code? You've got two repository, the docs repository and then the hackathon repository. And then that DEX example I showed you is under the smart contracts under Algorand. So in summary, we covered a lot of things here today. The blockchain use cases, the layer 1 features with assets, atomic transfers, and smart contracts. The use cases, DeFi, the biggest use case going. A lot of folks are able to also create games now. Gaming is very big on blockchain as well. And then this is the office hours link. So you want to go out to algorand.com/developers. The next one is going to be using that last tool I showed you, the AlgoDEA. boy, it is just great. I just started recently using that myself, and I am amazed at the productivity I have doing that. So PowerPoint is right here. Is the link. This 3THONSV. And Discord. Oh, we got a really nice community going on Discord. Please join. There's the link for that as well. A lot of great resources, a lot of tutorials here. These are all in the deck. Community tools, Algorand Studio, AlgoDEA. You got another one. This is pretty cool. This playground. AlgoDesk we saw. There's also the teal piece to that, smart contract piece, REST API points that I showed you with the build in Postman, and rekeying information. That was our award we won. I hope you enjoyed this session tonight, and happy developing. Hope you do some blockchain apps. If you do, keep in the loop and let us know. Thanks, everybody.